So today we'll be looking at conditional operators. Okay, so we're focusing on size of operators, logical operator, bitwise operators, which is like bit manipulation, and conditional operators. I think we've talked about the size of operator before in the previous lecture. I think I can even choose to skip that part. But just let me just do a small recap about what we did as per that aspect. If you haven't seen my previous videos on that, you might need to check that out. So standard input outputs as H, main. Okay, so let's just do a quick one. So if I have something like int x equals to 4, printf. So I want to print the size of, so know the size of the data type. So I'll say size of int return 0. Okay, so I think I remember saying that whenever we're using the data type itself, we have to put them within a bracket. Okay, so once you see the size of int, sure, let me change this number to something else. Let me just say 10, so it won't confuse you. So looking at the output to this, we got 4. Because 4 is the data type size for integer. Okay, so another way of doing the same thing, if you don't use the data type directly, you can just write x, that's the variable that represents the int x that represents the data type. So then you need to put in brackets in this aspect. So if you run this, it should give you the same outputs. So you can see it's still the same thing. So the same process for doing floats, for doing char. I think char data type, the size of char is 1. So let me just do char. So char data type, I believe we are aware that this kind of space is also a data type also. So if I say size of x, it should give me 1 empty character. So let's say something like 65. So you can see it still give me 1. So it doesn't really matter what is within your x, okay, your what you are assigning in the character. It doesn't really matter. What we are focusing on in this size of is just checking the size of char data type. You understand? So whatever value is here doesn't really matter. It doesn't really matter. It will still take the same memory size of what char is, which is what 1 byte. Okay, so that's 1 byte of code. So integer is 4 bytes. Okay, floats is 4 bytes. Double is 8 bytes. Yeah. So that's it about that. So let's quickly just move on. We already understand this aspect already, so I don't want to waste time on it. So let's go to the next part. So we have the logical operators. That is the and, or, and negation. So this is the and. For the aspect of this and, let me just quickly say something. For the aspect of this and, both sides have to be true for the final result to return as true. Okay. And if both sides too are false, it will return as true. Okay, so we're confirming the two sides. Those two sides must be saying the same thing. But if we have something like this, true and false, this will give us false. And if we have false and true, this will give us false. So we just need a case where both of them should be the same thing. True will give us true, false will give us true. But anything like true false or false true will end up giving us false. Okay, so those two conditions on both sides must be the same thing for it to give you true. And when we come to logical operators, when we're talking about true, false, true is just like saying 1. So 1 represents true. 1 represents true also. 0 represents false. 0 represents false. All right. So let's quickly see a quick example as to these aspects. Okay, so let me just quickly clean these parts. So we have int num, which I just declared num. So let me give num a value. So let me say num is equal to 5. Let me use 6. So if I say printf, so the AND operator yields, that produces the answer using our percent %d as our format specifier. So now what should this percent %d bring for us? In short, probably let me just create another variable to make it easier. Let me say this is what should I use? What should I use? Let me say this is test. Okay. Now in this test aspect, I want to check these conditions if both sides are true. So I want to check if num %2 is equivalent to 0, and let me give them some space, and num %3 is equivalent to 0. Okay, now looking at this condition, let's look at this test statement now. Let me use comments. Now this num, we know num as 6, right? And 6 modulus 2, what will it give us? It will give us 0. Just like saying 6 divided by 2 to give us 3. There is no remainder, which means it will give us 0. So that means num %2 is equivalent to 0. That means this first part here is true. Okay. Now let's see the condition for the second part. We have num, oh sorry, this should be percent. Num %3, that's num modulus 3. And our num up above is still 6. So 6 modulus 3. So if we say 6 divided by 3, that will give us what? 2. There is no remainder, right? Which is still 0. So that means like saying 0 is equivalent to 0, which is also true. So now we have true in both sides. So we have true, we have true. What will be the output for this? I expect you to know by now. True. Okay, so that means this condition here should run as true for us. So let me place that condition here as tests. Okay, all this long stuff that I wrote here, I can choose to write it inside here, but I just want to write it inside, so it will not make this printf long unnecessarily. Okay, so I just declared the variable here, so I have to add the variable here. I think that's tests. Okay, so let's run this. Printf error expected. Okay, I forgot to put my semicolon at the ending of printf. Okay, so let's build and run this again. So you can see the AND operator yields 1. Don't forget what I said. I said true means 1. Okay, so whenever you are saying 1, it means it is true. Okay, so we are good to go. Let's another example, still using the same one. So let me change this to 3. Okay, so let's see the conditions. Now if I change that to 3, so that's num %2, right? That's 3% 2. So 3 modulus 2 will give us what? 1. Because we say, like, how many 2 can you get from 3? You can get 2 only once. Then to remain what? It will remain one more number, one more 1. Like 1 will be the remainder, right? So that will be our 1. That's why our answer there is 1. So that means 1 is not equivalent to 0, looking at this condition here. So this part is false. Okay, so keep that in mind. This part is false. So let's test the next condition for this next one. We have num %2. So that's like 3% 3. So the modulo 3 modulus 3. So 3 divided by 3 is what? 1. There's no remainder. So this is true. Okay. So it is, sorry, this is 0 rather. As in 3 divided by 3 is 1. There's no remainder, which means it is 0. Okay. So 0 is equivalent to 0 here. which is true. So we have the first condition was false, and we have the next one as true. So our final answer will be what? False. Okay. So this will be false, which means our answer should give us 0. So let's test that. So you can see the AND operator yields 0. So that's just all about that. Let me see. Now looking at this one, the logical OR operator, the way this one works is just that if we have two, if we have two, so if we have two, yeah, it should give us as true. If we have two false to give us as true, in as much as the focus of this logical OR operator means that it just wants to say at least one true there. So it doesn't really matter how the arrangement is. In as much as there's at least one true, it will return the final output as true. Unless if there are two false, like this last condition here, false, false, that's when it will give you false, which is what? 0. Okay, so don't forget this. So true, 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 false, true, true, false, false, false. Okay, so the logical OR operator, its focus is that just anyone that has true in either side will give the final value as true. And if there's no true at all in either side, then everything will be false. Let me think of a question that relates to this one. Let me see. Okay, we're talking about OR operator now. For the OR operator, let me use this. Let me use the same example, and this time around, let me use the OR operator. I think in this place, this one was false, right? While this one is true. So remember what I just said just now. If we have false and using the OR operator, then if we have true, our final output should give us true, in as much as there's at least one true. So if we print F this, we're going to see 1 as our answer this time around because of we are using the OR operator. We're not using the AND operator. All right. So let's see that. So you can see the operator yields 1. Okay. So I want to do it in a way that it will give us false, false. So this will give us false here. This one will give us false. Yeah. And mind you, whenever you are having something like this, whereby, like for example, now looking at this part, now we have norm percent 5, right? If we have 3 modulus 5, if you notice, the 5 is bigger than the 3. Okay, as if you want to do 3 divided by 5, it will look like it doesn't really make sense, right? So whenever you have a modulus that's whereby the right hand side, or sorry, the left hand side is lower than the right hand side, the final answer will be the left hand side. So just keep that at the back of your mind. So I mean, that means this place now you see 3 equivalent to 0, which is what? False. Because 3 is not equivalent to 0. Okay, so now we have two false here. So the first one here is false, because this one we have remainder 1, and 1 is not equivalent to 0. So false, false. So false, false, in terms of the OR operator will give us what? False, which is what? 0. So I expect to get 0 from this. So let's see that. Good. So that's it. The OR operator yields 0. Okay. What next? What next? Okay, we have the negation operator. Well, just this negation operator, just see it like opposites. Like for example, if you check for a condition and that condition is true, then once you put that negation, that means it will just tell you the opposite of it, which is then false. What I'm trying to say is that, for example, if I give you something like 4 is less than 8, we all know this is true, right? Like this is true. Then if I put the negation sign here, then it is saying it is the opposite of the answer that will give us the answer in this case. Remember, we said it was true, but that negation now has made us choose the opposite answer, which is what? False. Okay. So let me give another instance. So if we say 8 is less than 4, sorry, 8 is less than 4. Is 8 less than 4? No. So it is false, right? But then if I now place this negation there, that means I'm saying the opposite of it. And that means instead of me saying false, I'll say it is true. Okay, so just keep that at the back of your mind. That's how it's being called. So let's just see maybe a quick example as this aspect. It's not something really stressful to do. Just look for a simple basic example to use to explain that. Um, let's say norm 5. Um, let me declare another variable. I'll name this one. Let me just use the same test. I don't want to crack my brain so much this time around. So tests. So let's test. Let's test something. So if I say norm less than 5, then I will print f. I know I've not put the negation sign. I know I purposely do that. I want to just show you something. This yields something, right? So I'll use my percent %d. So I'll put my tests. Don't forget the semicolon at the end. Okay, now let's test this condition. Now, is norm less than 5? Like, let's think now. Is norm less than 5? No, which means it is false, right? So that means we're expected to see 0 here. So let's check that. So you can see this yields 0 as false. Now, let me put that negation sign at the front of this. It will give me the opposite of the answer, which is what? True. And 2 is what? 1. So this is it. So I think this example is enough to understand everything that you need to know concerning the negation. So just have it in mind that in terms of negation, the logical negation operator is a unary operator. That is, it only takes one operand. Remember, each of these ones takes two operand, one at the left hand side, one at the right hand side, like two conditions at both sides. But when it comes to negation, it takes only one condition like this. Okay, it doesn't have any two at the sides at all, just a single operand or expression at the right hand side of the exclamation mark. Let me just do a quick just one last one. So if I put equal to these two equal to signs there. So I'm saying norm is equivalent to 5, which is actually true, right? Because norm is 5. I'm saying 5 is equivalent to 5 is true. But then, and I put this negation, that means to give me false. Let me cancel this and run this. So this should give me the opposite of it, which is false. That's why we have 0 here. But let me clean this, and then we should see that it should indeed give us true on the norms, aside the negation being involved. So I'll build this. You can see this yields 1. So it's not say if you all this stuff we are putting here, just keep it in your mind that we can choose to not use these tests. Yeah, just purposely choose to use it that way. You can choose to also put your conditions here like this. Okay, it will still work fine for you, which means I won't need this test that I declared the variable. So that means we have actually saved some memory like this. Instead of having two integers, which will take total of 8 bytes. So we're having still 4 bytes and doing everything within it at once. Okay. And yeah, sorry, it just occurred to me that whenever, for example, in this AND operator now, remember I said when it is true, true, it should give us true. Then when it is false, false, it should actually still give us false. Okay. So that means the case where we are going to see only true here is if both sides are true in terms of the AND operator. So both sides must be true for it to return as true. Okay. So looking at this quick example now. So where we have this place, we have norm as 7. So if you say 7 is equivalent to 5, which is false, right? Also, 7 is equivalent to 6, which is false. So we have false, false here. So we can test that by seeing the output of this. This should give us 0. So you can see this yields 0 for us. Okay, so when it comes to AND operator, just place it in your mind that it should always be true in both sides for it to be true as a total final answer, or for it to be one. Okay, so that is one of the conditions of that AND operator. Now, it then applies to the AND operator on this our bitwise operator here. So for the bitwise operator, just quite similar to the logical operator that we've talked about. So what it's trying to say is that the same logic, if we have one here and we have one here, it should output one for us as true. Okay. So if we have 0 and 0, it should output 0 for us. All right. So just place that back of your mind. But if we have something like and 1 0, it will give us 0. So it will only give you 1 only when both sides are 1. That's going to give you 1. Okay, so that's just what bitwise is all about. So when we have something like, when bitwise is talking about bits, so we're talking about binary here. So we need to now to convert from base 10 to base 2, or base 16 to base 2. Very, very important now to convert to binary. Okay, so that's the first step. Because this bitwise, we're working with decimals. We're working with binary, that is 1 and 0. So for example, we have something like this 1 0 1, and let me say 1 1 1. Now the output of this result would be the first place here we have 1. Also the first place in the other side we have 1, which is both sides are 2, right? So we're going to put 2. Now looking at the next part, we have 0 in this next part and we have 1 here. That means we have 2 and we have false. That means to give us as false as the final answer. In this last part, we have 2 and we also have 2 in this last part, so to give us 1. So this will be the answer in the final answer after checking the AND operator. Now, the advantage of me trying to let you know that you need to know how to convert to base 2 is because, for example, when we want to solve all this stuff in C, we won't just be writing all this stuff in binary. We'll just write the normal decimal number, that's like whole numbers, which are 10, which are actually base 10 itself. Okay, so it will convert those stuff for us internally to binary. All right, so let's say for example now, if this is 7, for example, okay, if this left hand side is 7 and maybe this right hand side is 5, so you have to convert the 7 to base 2 to give you this decimal, then the 5 will convert to this to base 2 to give us this, then to output this in the binaries. Then from this binary you have to convert it back to the base 10 that it started with. Okay, so the final answer, we're going to convert it back. So something like that. So that's just how it works. Let's see a quick example of how to go about that. Okay, so let me just use only the norm. I'm going to print norm. So let's just see a quick example as regards to that. So we have something like 5 and 6. Now that, and don't forget, is a sign of bitwise. Okay, so what this does is that this 5 is in base 10, so you're going to convert this 5 to base 2. Okay, so go back to your primary school maths to now to convert from base 10 to base 2. So 5 to base 2 will give us 1 0 1, and then convert 6 to base 2. So 6 to base 2 will give us 1 1 0. Now let's check the conditions in their bits using the AND bitwise operator. So here we have one here, which is both sides are 2, so to give us 1. Now looking at the next part, we have 0. The next part here we have 1, which means we have false and we have 2. That means to give us false. Remember the condition of AND, both sides must be 2 for it to be true. Okay. Now lastly, we have 2 here, which is the 1 here, and the last part here we have 0, which is the false. So we have 2 and false. That means to still give us the same false, in as much as both sides are not true. Even if we have false false, it's to give us false. Okay, don't forget that. So that's it as for this part. So we have 1 0 1, we have 1 1 0, then bring out 1 0 0. Okay, so now from this binary, from this base 2, now that we have this 100, convert it to base 10. Solve it with your Bible, with your pen, in a piece of paper. Convert 100 base 2 to base 10 and see what the output should give. The output expectedly should give us 4. So let's check this. Now this will give us the final answer in the base 10, which we started with. Remember, this question started with base 10, 5 and 6. So to give us our output answer also in base 10. But I'm just explaining to you how the result came to be internally. Okay, so this is just a raw explanation of how that result came to be. So you need to understand this very well. So the same rules apply to each of these ones also. That is this OR operator. This OR operator also works like the OR operator of the logical operator. Okay, so just that it deals with bytes this time around, that it deals with 1 and 0. So be testing each side if they are true or if they are false. So for example, in this case, if we have something like 0, 1 and 1, 1. Now this should give us, where the first part we have false, which is 0. And here we have true. So when it comes to OR, remember the logical OR. Even if at least one of them is true, it will return as true. So this will be true. At the last part, we have true here. We also have true here on the other side, which is still true. Okay, so this is the answer in terms of the bits aspects. Then you can then convert it to base 10 to get your original value. So that's just how everything works in this regard. Okay, so even if you change this place to or to give you its own answer. So I don't want to stress myself breaking it down again for you in this part. Or okay, let me just talk. Let me just try for this part. Okay, now if we have this using the same using the OR operator, we have 1, we have 1. So both sides are true in this part. So we're going to get true in as much as both sides are true using the OR. Okay, the condition of the OR is that at least one side is true. So even if both sides are true, it still give us true. Okay, now here we have 0 and we have 1 in the other side, which means we have at least one of them is true, right? So it still give us true. Now the last part, we have 2 here, that is 1, and we have 0 in this last part. Then we have 2 and we have false. Well, at least one is still true, right? So we're going to get true. So now if you convert 111 base 2 to base 10 to give you the final answer of this output. So let me build this and see the value in base 10. Value in base 10 is 7. So you can test that for yourself if you will get 7. When you convert 111 base 2 to base 10, you are expected to get 7. So that's how the results came to be. Okay. Now we have the bitwise exclusive OR. Okay, I think this is a new. I've not talked of this one. There's no exclusive OR in the aspect of the logical, so I've not mentioned this. So let me just explain what this one does. Now the exclusive OR operator places 1 in the result if exactly one operand but not both is 1. Okay, if exactly one operand is 1, what I'm trying to say concerning that, if we have 0, this sign, and something like this. Now the output to something like this will give us, if both sides, what the condition is saying now, if both sides are 1, it will give us 0. So looking at this part, we have 0, we have 1 in this first place. So in as much as both sides are not 1, right? So this will give us true. But if both sides are 1, we have 1 here. In this last part, we have 1 here. It will give us 0. All right. So the same thing, even if we have 0, 0 here, for example. So that means if I say looking at this, the first 0 here, the first part here is 0, right? And here is 1, which means we have at least 1 true. So we're going to take 2. But now we have 2 false, false, false. So we're going to take false. So the point is that whenever both sides are the same thing, it's always false as far as this exclusive OR is concerned. Okay, if we have true true, it will give us false. If we have false false, it will give us false. Unless when we have true false or false true, that's when it will give us true. So that is the role as far as this exclusive or is concerned. All right. So that's just how to go about that. Let me see if I put the exclusive or here, exclusive or. So let's see what our answer would be here. If we have 1, 1, you can say we have 2, 2 here, which means we have 1, 1, which will give us false because both sides must not be the same thing as far as this exclusive or is concerned. Now we have false here and we have true inside here. That's 0 and 1. That means this should give us true, which is 1, right? So here we have true and we have false here. So since we have at least one true, it will give us true. All right. So let's assume, I know this is actually the final answer to this. Okay, I just want to say one more thing. Let's assume we have 0 here. Like if you're using another number, maybe we have 0 here. So we have 0 here, we have 0 here. This final part will also be 0 because both sides are false. So if both sides are false, it will give us 0. If both sides are true, it will give us 0. All right. So in this particular case, this is the limits, the binary numbers. Okay, so you can convert 0, 1, 1 to base 10. It should give you the result we are going to get in this code. So let me build this. So the result here gives us 3. So you can try converting 0, 1, 1 base 2 to base 10. This should give us 3 here. So this is how the exclusive OR works. Now we are in the bitwise complement operator. The bitwise complement operator just work like that logical negation. So that negation part of opposite part is just the same thing with what this one means. All right. So if we have something like this, if we have something like negation of 0, 1, that means the answer to this will be this place where it is 0. The first part that is 0 will change to 1. While this place that is 1 will change to 0. So just as if they'll just change in their opposite formats. Okay. So that's just what this means. And when it comes to the aspect of this complement operator, which is called complement operator here when it comes to bitwise. But when it comes to logical operator, they call it negation operator. Okay. So it just works the same way like the logical negation, whereby it has only one operand after the exclamation mark. So there is nothing like two things. There is no side by side stuff like this. No, it's always just like this. Okay. So always keep that at the back of your mind. So it's always like this. Okay, now so that's it about the bitwise complement operator. So lastly, looking at the right shift and the left shift, now you need to really pay attention closely to this. Okay, the aspect of this right and left shift aspects, but it's actually simple though. You just follow this pattern of rule. Let me explain it here before I start doing the code of it. So let's take for example, we have 7. Now imagine we want to focus on 8 bits. Okay, so we want to focus on maybe 8 bits. I think float is double. Okay, yeah, double is 8 bits. Yeah, I mean 8 bytes rather. Okay, so let's assume we want to work with 8 bits now. When we talk about bits, remember bits is different from bytes. So bits is like for example, 1 bit is like saying 1 or 0. 2 bits is like maybe 1, 0, 1, 1. You understand? Binary, just those normal 1 and zeros. So those are what we call bits. So let's assume we want to work with 8 bits now. And we have that x is equal to 7. But then in its bits binary form, that's the 8 bits, we have 111. Okay, so 111 will actually give you 7. Okay, so but since we are working with 8 bits, we have to complete this bit to be 8. So yeah, we have only 3. So let me put 8 at the start of it. So that is how many? That's 2, 4, 6, and put one more 0. So this is the how it looks like in the binary form. Okay, so the value here is actually 7. 7 is the same thing as this stuff in binary. Now, if for example I give you something like this, or just to make it simpler, let me not make things look weird. Let me put 7 here. Now, this 7 is this stuff we are seeing here. Now, this part we are talking about, this is for left shift. Okay, I'm even doing left shifts here. Okay, Now, once for we are doing left shift here, okay? We'll still do right shift, don't worry. So now, since these two arrows are facing to the left side, so this is left shift. So what this left shift means that it will shift this value, whatever value is here, to the left. Okay, that means you can see at this ending we have 1 1 1, right? Now this 1 1 we move one step forward. That means this first one here that I'm touching here will move to this zero. We replace this zero. Why is other one move to this next part? Why is other one move to that means there will be an empty space here, and we're going to give that part as zero. And this is what I'm saying. The code will change. The bits format will change to something like this: 0 0 0 1 1 1 0. So you can say we moved it just as if we move it to the left one step. So each of them move in one step. So something like that. So if, for example, now if I say 2, yeah, that means I want to move them in 2 steps. That means I'll move it again. That means this one move to this 0 part. So this place will change to 1. Why the other one will move here? Why the other one will move here? That means this last part will be 0. So I just shifting them like that. Okay, so that's what, if you even notice the shift, you notice here we have two zeros here, so it means like two shifts. Okay, that means if we want to make 3 shifts here to the left, that means I'm going to have 3 zeros behind. So that means I'll claim this place, maintain 0 here. That means this fourth place we have 1. Remember, we have to still make sure it remains at 8 bits curve. This time we're working with, assuming the machine is working with 8 bits. Okay, so that is why it is always in this format. So this same principle applies to right shifts also. Okay, so it also applies to right shifts. Let's see the aspect of right shifts. Now, if we have something like x is equal to 192. Now, this 192 in its binary form using 8 bits. Okay, so we have 1124. Okay, I think the zeros are complete here like this. So this is how it looks like in binary format. Now, if I say something like 192 right shift, so I want to right shift it once. So it's just the same format. Since now this time around we're going to the right direction, which means we're pushing this 1 1 forward like this to the right direction. So that means this one will replace this 0, and this other one will shift to this other side. Then we'll have an empty space here, which is the 0. So this will look like this: 1 1 0 0 0 0. So we will shift it one step to the right side. For example, if we want to shift it 2 times, so that means we are shifting it 2 times. That means there will be 2 zeros here. Okay, since there are 2 zeros here, that means most likely we are going to remove 1 zeros also, just so that it will maintain the same 8 and to be shifting like that on and on. So if we have 3 here, we're supposed to have 3 zeros here. So since we have 3 zeros, I'm going to claim 1 0 at the forward side, so to show the aspect of the shifting. So we're shifting it 3 times. Okay, so that's how it works. Just be shifting like that, depending on the number given in this format. So you can see it's actually very simple. That's just what the whole shift concept is talking about. Now, looking at this picture here, we have, okay, example, we have this binary given, and we have the left shift as 1. So that means we are shifting it to the left in one step. So that means this first one that is here will go forward. While this other one also will go forward. While this 1 1, which is like 11, will move forward again. Okay. So that's what they are just going to do simply. So that's why the output is like this. You can see this first one. As soon as this first one is moving forward, it will change to 0. That's why we have 0 here. And also the rest too will move forward. Okay. So you can see that's just what they did here. Same thing with this right shift. So this right shift, we are moving to the right direction. So all of them, and since it is 1, that means we are taking one step. Assuming it is 2 shifts, we are taking 2 steps. So each of them will be taking that step. So this one will go forward. But since we are working with 8 bits, so it has already passed the 8 bits, so it will just disappear. It will remain on this 0 here. That's why we have that last 0 here. But if you notice this first one here, it moves forward. It replaces this 0 that is in this place. Then since it moves forward, here will be empty, right? That's why we place the 0 at the front part of it here. behind. So that's why we have 0, 1. Same thing, we shift this other 1, 1 forward. That's why they are shifted like that. So that's just what your concept of right shifts and left shift operator is all about. And it's actually not hard. Okay, so it's not hard at all. So you can see questions that may involve it that looks like also to still deal with using the using base 10. Okay, so just get that part straight in your mind. So it depends on if I see something like x, let me use x. So let's say maybe let me see the values I've used for this example. So if I say 192, sorry, 192 right shift 3 print f, um the result is send d x. So we run this code to give you our answer as 24. So that means what it means is that, remember we just did this part here. So convert this part to base 10. Convert this 0001100 to base 10. It should give you 24. That's what it's just trying to say. So this answer we are getting here, we are first checking it in terms of bits. We want to check it in terms of converting the bits to base 10. It will give you 24 as the answer. So this is 24. All right. So I just chose to explain how it works inside so that when you see code like this, you'll not be like, how did 24 happen here? So now explain how you get to test it. You want to solve it yourself. Just convert this to base 2, that's to binary. Okay. So once you convert this one to binary, then make 7 shifts. I mean 3 shifts. Okay, to the right. All right. So that's just how it is. Can see it's not actually hard. Same thing if you are changing it to the left. So just make 3 shifts to the left. The answer will be different. I'm pretty sure about that. So you can see the answer is very, very different here. Okay, so try this one and try solve it raw with your hand. And try see if you will get this particular value here. To be sure that you really get what I'm saying concerning this bitwise. So convert this to base to binary and then make that 3 shifts to the left side and see if you will get this output. Okay, I think that's just it about that. I think since we are dealing with x, I want you to note something here. Remember, we're dealing with integer of x. And integer, what's the byte of integer? 4 bytes. Integer works with 4 bytes. And we know that 1 byte, we know that 1 byte is 8 bits, right? So that means since we have 4 bytes, so it's going to be 8 times 4, which is what? 32. So that's 2 bits. Okay, so 32 bits, that's what it means here. That means when we are doing this stuff, one want to maybe attend this stuff in these aspects. Remember, the example I use, we limit ourselves to 8 bits. Okay, so this 32 bits means it can be longer than that 8 bits in terms of since we are dealing with integer here. Okay, so it is actually 32 bits in terms of using integer. So I just use that 8 bits just so you get to understand the concepts about everything, which means it can actually be bigger. The zeros and ones can be longer. All right. So that's just it about that, just so you know. So lastly, I think we are at the last part of this lecture, the ternary operator. So the operator, which looks like question mark, is called the conditional operator, or popularly known as the ternary operator. Okay, which is the only operator that takes 3 operands. We have one, we have one, we have one here. So it takes 3 operands. What it just means is that it just tests if the first condition is true or false. If this x returns true, it will run the y. If this x returns false, it will run the z. That's just what it means. Okay, so it's not something complex at all. So it's first test the condition of our x here. So whatever value this x gives us, if it's true or false, it will determine which of them it will print out. So like I said, the first one, y is the true session. So this part is the true session. while the last part is always the first session. So let's see a quick example as for this aspect. So quick example, if we have something like int num equals to 3, then I place this kind of condition now that num modulus 2 is equal to 0. I'm checking now if it is equivalent to 0. Like I'm asking, is it equivalent to 0? That question mark is just like a question. Num modulus 2 is just like saying, is num modulus 2 equivalent to 0? True or false? If it is true, print even number. I'm just giving any sentence there. But if it is false, print this other thing. So print odd number. So I'm going to close this, I think, with a semicolon. So this is just all we need. So now what this code is saying now, if we check here now, num 3 modulus 2 will give us 1, because you are going to have 1 as a reminder, and that 1 is not equivalent to 0. That means this thing is showing us false. Okay, that means it's going to print odd number, because this place is the false condition acceptance here. If it is true, it will print this even number. So let me run this. You can see it prints the odd number. So let me put this new line so it will space out. So let me just quickly look for a condition that will print us true for us. So let me just change this to like maybe 4. So this will give us 0, because 4 modulus 2, there is no reminder, so which is 0. So 0 is equivalent to 0, which is true. So to print this true condition here, which is this first part which says even number. So build this, you can see it prints even number for us. So that's just what ternary operator is. Another way of using this ternary operator is using the if and else statement, but we'll talk about that later. Okay, so just understand the basic concept of ternary operator. Here will be the condition asking if it is true or false. So if it is true, it will print this first part. If it is false, it will rather print this last part. That's just how it is. That's how the format always remain. All right, so I hope you understand. So that will be the last, I think this is the ending. Yeah, this is the ending of our lecture. Please, if you don't really get this video, just rewatch it several times, okay, till you get it. Rewatch it till you get it. All right, don't just be rushing. All right, I hope you understand this very well, and try to attempt them, try to solve them with your pen, just so you understand the concept of everything. Okay, so that's it about this video. Have a lovely day. Bye.